I am Kalidas Topada. Welcome to Quality and Welding Metallurgy. Today we are discussing a question related to mechanical design fundamentals. What are the failures with reference to the structural design? Answer is failure of structure part can occur by excessive elastic deformation, B. Excessive non-elastic deformation, C. Fracture. Any design has to guard against the perceived failure. What are the factors upon which the mechanical properties of mechanical art depends? Answer. Mechanical properties of any materials of construction are depend on chemical composition of the material, method by which the material is manufactured. What is stress? Answer. It is defined as the applied load per unit cross section of the specimen. The common units are PSI, kPa, MPa, kg per square centimeter. What is strain? Answer. For tensile load, it is the ratio of increase in length of the specimen under constant sustained load to the original of specimen the load is applied. For compressive load, it is the ratio of the decrease in length to the original length under constant load. Sustained load. Strain is thus an observed and measurable quantity as the extension for compression of the specimen can be directly measured. It is dimensionless quality. Draw the stress-strain curve showing the behavior of the specimen under stress. When there is no load, there are no stress and no strain. When small tensile load is applied, the strain can be measured and stress derived. If the load is removed, the specimen returns to its original shape. That is, there is no residual or permanent strain in the specimen. Thus, situation continues up to the certain level of stress. A stress-strain curve is this region is a straight line, like stress is proportional to strain. Thus, this region of curve is called the elastic region as the MOC. Behavior is elastic like a rubber. MOC means material of construction. As the tensile load during the test is increased further, a situation arises when the specimen does not return to the original dimension, even when the load is withdrawn. This also level of stress level at which the stress-strain curve being two divided specimen are undergoing plastic deformation in addition to elastic deformation. When the load is withdrawn, the elastic deformation is recovered, but the plastic deformation stays. What is upper yield point with referred is above stress-strain graphs. Answer. The highest stress that metal can withstand under the sustained load without the continuing to elongate it under the same load to the called the upper yield point. What is lower yield point with reference to above trained graphs? Answer: the lower yield point to determine the yield strength of the material being tested called the upper yield point is momentary. What is the effect on the specimen when the subject to a sustained load with higher temperature? Answer: as the temperature of the test increase, specimen of the same material would elongate it more for the same load as compared to specimen tested at lower temperature. It means that the material becomes softer as it is subject to higher and higher temperatures. What is allowable stress? It is defined as ultimate tensile strength divided by factor of safety. The safety factor is obviously greater than 1. Design which ensure that the trace value anywhere in the structure is less than his allowable stress are considered safe as they do not allow the structure element to come anywhere close to the point where the plastic instability leading to the disruption and disintegration of the element would set in. What is the value of allowable stress if yield stress or 0.2% proof stress value is available at design temperature? Answer: if the yield stress or 0.2% proof stress value is available at design temperature, the same shall be divided by safety factor of 1.5 to get allowable stress. What is the value of allowable stress if the yield stress is not available at design temperature but is available at room temperature? Answer: if the yield stress is not available at design temperature but is available at room temperature, the same shall be divided by safety factor of 3 to get the allowable stress. Sorry. What is the value of allowable stress if the stress value for rupture due to static failure or creep failure is available at the design temperature? Answer: if the stress value for rupture due to static fatigue or creep failure is available at the design temperature, the same shall be divided by the safety factor of 0. Or same safety factor or 1.5 to get allowable stress. How much design temperature shall we consider for the structure part which are heated by steam, thermic fluid, etc.? Answer: design temperature shall be the highest expected temperature of the heating media or highest expected body part temperature plus 100 degree centigrade. Here 100 degrees centigrade is the safety margin. What shall be the safety margin considered for the fired vessel part which are shielded and the part which are unshielded? Answer: Safety margin for shielded part 200 degrees centigrade. Safety margin for unshielded part 500 degrees centigrade. Note, the above safety margin are just guideline. What should be safety margin would depend upon the severity of operation. Define proof trace. Sorry. It is also called 0.2% proof trace. It is trace for 0.2% strain. In simple terms, it is stress value per strain value of 0.002% on the stress strain curve. How the proof stress in the material is altered, increased marginally. Consider the stress strain curve and show above. Let fresh specimen be subject to gradually increased tensile load. A 0.2% proof trace can be marked on the curve as the stress value corresponding to point C on the curve. Let the load increase beyond the point up to point D. On the curve, the specimen has surely passed elastic range and crossed over the plastic deformation. On withdrawal of the load, the specimen would return back to the point E with the residual permanent strain as shown above. The tensile load test can now be conducted on this specimen which has been plastic deformation or cold work previously. The specimen would now follow a stress strain curve with strain 0 at point E. Along the stress strain curve, 0.2% proof trace corresponding to point G, which is higher than the proof trace for the fresh specimen. The material in the above case seemed to have hardened with its experience the strain earlier. Most material shows the marginal increase in their proof trace due to the cold work. What are the type of the failure encountered in piping? Answer: catastrophic failure. Second, fatigue failure. Then define catastrophic failure. Answer: the failure which occurs suddenly as soon as the load crosses the threshold, ultimate tensile strain. This failure takes place on the first occurrence of the load in excess of the yield trace. What is the fatigue failure? The failure which occurs due to the damaging of the grain structure of the specimen subject to prolonged application or sustained load and or tensile compressive load cycle. What are the type of fatigue failure? Answer: type of fatigue failure are A. Static fatigue, cyclic fatigue. What is static fatigue? Answer: the specimen which fails under sustained load subject to the considerable length of time, the total time of the which the load was applied, id important whether it is applied continuously or in installments is not important. What is cyclic fatigue? Answer. The specimen which falls under a load cycle subject to considerable number of times. The total number of cycles for which the load was applied is important. Whether the cycle was frequent or infrequent is not important. Explain the failure of the specimen subject to cycle load. Answer. Consider a specimen subject to the tensile load increasing from 0 to x, and then this load is gradually withdrawn till it is 0. Now, compressive load applied gradually till it is 8 into then it is drawn till the load 0. The compressive cycle and is repeated again and again. With each cycle, the grain in the material get displaced relative to each other and get more and more interlocked. With each cycle, the material lost its ductility in small increments. A time comes when the grain are so badly interlocked that they cannot allow deformation to withstand load and small crack develops. The crack grows with further cycle and failure occurs. Sorry. What is creep failure? Answer. Occurrence of static failure when the material is under prolonged sustained load coupled with higher temperature is called creep failure. Write the sequence of stress value at the failure for solid rod, sphere, and cylinders. Answer. A typical sequence of stress value at failure for solid rod and to most important shapes in process industry, namely sphere and cylinder, and sphere and cylinder is rod, sphere and cylinder. Thank you.